Okay, let me do another example. Here we want to find the interval on which this function is concave upward and concave downward. So first, we need to know what is the second derivative of this function. So we start with the first derivative. For this function, to find its first derivative, we are using quotient rule. So we square the denominator and we take the derivative of the numerator and times the denominator minus we take the derivative of the denominator and times the numerator. So we have the derivative of this term is 2x times x squared minus 4 and minus 2x times x squared plus 1. Okay, if we fact out 2x, so we have x squared minus 4 minus x squared plus 1. So we can see x squared and x squared are cancelled out, and here we have negative 4 minus 1, so that's negative 5, and negative 5 times 2x, so we have negative 10x. Okay, now this is the first derivative. To find the second derivative, we take the derivative of this result, and again we're using quotient rule. So and minus the derivative of the denominator times negative 10x. And the derivative of this term is negative 10. The derivative, to find out the derivative of this term, we are using chain rule. So first we take the derivative of the outer function, that is 2x squared minus 4, and we'll take the derivative of the inner function, that is 2x. Now 2 raised to 2, that's 4. Okay, so we have negative 10x squared minus 4 squared. And here we have 2 times 2, so it's 4x. And times negative 10x, so 4x times negative 10x, that's negative 40x x squared. So this is negative 40x squared. And negative 10x squared minus 4 squared minus negative 40x squared, so that's plus 40x squared times x squared minus 4. Okay, then we notice they have a common factor, which is a 10 and x squared minus 4. So we can factor that out, and we are left negative x squared minus 4 plus 40x squared. So finally, the second derivative is 39 x squared plus 4 over x squared minus 4 to the fourth power, and the x squared minus 4 can be cancelled out. Okay, after we finish this, we think about when does the second derivative equal 0. If the second derivative is equal to 0, that means the numerator gonna be equal to 0. However, we can see that the numerator is 39x squared plus 4. Now this will never be 0 because 39x squared is always non-negative. So there's no solution. And then we want to consider when does the second derivative not exist. And to consider when does the second derivative not exist is equivalent to look at when does the denominator is equal to 0. And the denominator is 0 when x squared minus 4 is 0. So we found two solutions. One is positive 2, one is negative 2. Okay. Now then, we can divide the number 9 by using these two numbers, negative 2 and positive 2. And on each interval, we choose a test point. And we plug the test point into the second derivative. Okay. Now when x is negative 3, so this is gonna be 10 times 39 times negative 3 squared plus 4. And over negative 3 squared minus 4 raised to the power of 3. We can see this is 10 times 39 times 9 plus 4 over 9 minus 4 to the power of third. Now this is positive. Okay. So the second derivative is positive on the interval from negative infinity to negative 2. Now, if the x is 0, the numerator is 10 times 4, so that's 40. And the denominator is 0 minus 4 to the power of the third. And the denominator is negative, so the result is negative. So the second derivative is negative on this interval. And when x equals 3, the result is the same as when x equals negative 3. Why? Because 3 squared and negative 3 squared, they are both the same. So when x is 3, the second derivative is also positive. Therefore, from this result, we can know that the function is concave up on the interval from -infinity to -2, and concave down from -2 to +2, and it's concave up from 2 to infinity. So the inflection point are x equals -2 and x equals +2. Okay. The function has this graph. You can see from -infinity to -2, right? Since the graph it holds water, so it concave up, and from x equals -2 to x equals +2, the graph is concave down, and from +2, when x is from +2 to infinity, the graph it holds water, so it concave up, which is the same as our result.